Hey, welcome back to Math with Patrick. Today is February 7th, and we're solving problem number 38 from this Daily Epsilon calendar. Okay, let's try it out. Here we just have a math equation, and we're just solving for x. Apparently, the answer is 7. We need to find some number when we cube it and add it to itself, we get 350. There's a few strategies that do work for polynomials in general. Like sometimes factoring is a nice strategy to try to figure out some solutions to an equation like this. And so both of these do have a common factor of x. So I could factor out an x like this if I wanted to, just like that. You could think if I redistribute it back in, I get an x cubed here and then an x there. So I could reframe this question as like a multiplication question instead of an addition one, where I'm finding factors of 350, where one of them is like one more than a square. It still kind of feels like guess and check to me. I do know that if I plug in bigger and bigger values of x, this output will also grow bigger. So when I'm guessing and checking here, if I plug in a value that returns something too small, I know that the value itself is too small. So let me just make a table where I'll have x here and x cubed plus x over here. And let's just check some values. I do know that x cubed plus x is going to be roughly as big as x cubed. And so picking something like 2 is kind of too small because 2 cubed is still just 8. Picking 5 cubed, that's 125. That still feels a little too small, but why not? Let's just do that as like our baseline. 5 times 5 times 5 is the same as 5 cubed, and that is 125. Add on another 5, and we get 130. That's a little too small, so let's just bump it up one more. We got a 6. 6 cubed, I've memorized this one, is 216, plus another 6 is 222, also a little too small. And then if we try a 7, which is today's date, so this should work, 7 cubed is 343. I also have this one memorized, though you could verify it too with a little bit of mental math. 7 squared is 49, and you could probably do 7 times 50 in your head, and then just take off a 7 to get 7 cubed. And then at least for this problem, we are adding on another 7, and that gets us exactly to 350. So this right here is our answer. X has to be 7, and that's about it. So, I mean, you're free to go, but there's a few more things I'd like to share. Sometimes with polynomials, there are more than one answer. Like if you study quadratics, you know that usually there's 2. Like a quadratic equation like this, we have 2 answers. It could be 2 or -2. So even though I found an answer for this particular equation, it should be shown like that there aren't any more. One way is just to graph it. I know that the x cubed graph looks a little bit like this, and just the graph of x is a diagonal line like that. So when I add them together, it'll still have that characteristic curve of x cubed, but it'll kind of have like that slope of around 1 near the origin. And with this picture, it's pretty easy to see that this function is, vocab word, bijective. That means for every single input I have exactly one output. Something that's not bijective would be something like x squared, because another qualification you need for a bijection in a function is every output also needs a unique input. Though here with x squared, 2 different inputs could get you the same output. And so yes, it's a function, but no, it is not bijective. I can even ask a graphing calculator to graph this for me. And so you can kind of see how it's always just increasing to the right. And every single input is just going to have one unique output. There's never going to be any like doubling back over on itself in either direction. So here I can just look up until it hits 350. It's going to take me a while, so let me just zoom out, and there we go. And I know that, again, just kind of graphically, I can tell that it passes that horizontal line test. As in, if you place a horizontal line and kind of inspect the whole graph from bottom to top, it's never going to overlap in two spots. And to me, that's enough of a justification to call this a bijective function. And so here is the only one and only unique spot where we run into a value of 350. So not only does 7 work, it's the only number that works. And that is enough to prove that 7 is our one and only answer for today. So thanks for coming along. We found out that inputting 7 gets us 350, and we are all done for today. I'll see you tomorrow. Thanks for coming along.